In this tutorial, we will learn how to solve a two-way ANOVA problem using Excel. We have already explored this problem in detail, but let us revisit it with a practical demonstration. This is the problem we are going to solve today. 5 types of fertilizers are applied to 4 varieties of potatoes, each planted on 5 plats of land of the same size and fertility. The yields in quintals are shown in the following table. Fertilizers along the column and potatoes along the rows. Please observe the values. I am not going to read them. Test at 0.05 level whether 1. The effect of fertilizers and 2. The effects of potato varieties are significant on the yield of potatoes. As we are going to test the effect of two factors on the yield, we have two hypotheses. Let us state them first. Hypothesis 1. Null hypothesis. There is no significant difference in the mean yield due to potato variety. Alternate hypothesis. There is significant difference in the mean yield due to potato variety. Hypothesis 2. Null hypothesis. There is no significant difference in the mean yield due to fertilizer. Alternate hypothesis. There is significant difference in the mean yield due to fertilizer. Now let us go ahead with the Excel solution. First open an Excel file and save it. Already I discussed in detail about how to open, save and bring data analysis menu to Excel. Those who want to know these techniques are requested to view my one-way ANOVA in Excel video. So I shall skip those steps and start discussing the main steps. Let us enter the values in Excel. I have the table in my Word file, so I copy it. While copying, leave the fertilizer row. I mean the first row to avoid paste problem. For this, click the cell with the label potatoes and drag the mouse pointer diagonally and copy it. We have copied the required information. Go to Excel and paste it by selecting one of the cells that is convenient to you. I select E8 and paste it. Otherwise, you have to enter the table manually. In the ribbon, go to the Data tab and choose the menu Data Analysis. It is at the right extreme of the ribbon. Data Analysis window opens, showing the analysis tools in the list box. Select ANOVA two-factor without replication tool. Click the OK button. ANOVA two-factor without replication dialog box opens. We have labels in the first row and first column. So put a tick mark by clicking the checkbox with the caption labels. We are going to test the hypothesis at 0.05 level of significance. Already this value is displayed by default in the text box with the caption alpha. So leave it as it is. Otherwise, change the value according to your requirement. We are going to have output in the same page. So select the radio button output range. Enter the cell name or cell address in the text box. Select any cell where you want to have the output or result. I select E20. Immediately it is displayed in the text box. Now it is time to enter the cell range in the input range text box. Just click the text box to place the cursor in the text box. Then select the top leftmost cell of your data table and drag the mouse pointer to the bottom rightmost cell. You have selected the range in which your data are presented. This range is automatically entered into the input range text box. Now click the OK button. Excel displays the result at the chosen spot. Excel displays the result in two tables. Let us examine the first table, ANOVA two-factor without replication. It is otherwise called as summary table. It gives the number of observations in each sample, their sums, averages, and variance for potato varieties and different quality of fertilizers separately. What is important is the ANOVA table. In the first column, it displays the sources of variations. But remember, row represents potato varieties. Column represents different quality of fertilizers. In the second column, Excel shows the sum of squares. In the third column, it displays the degrees of freedom. In the fourth column, it gives mean squares. In the fifth column, it shows the calculated F values. The P values are given in the sixth column. In the last column, it displays the F critical value, otherwise known as table value of F. In this table, we are going to make use of the values in the last three columns to test the hypothesis. Let us test the first null hypothesis. There is no significant difference in the mean yield due to potato variety. This we shall do in terms of F values. Conclusion. In this case, the calculated F value 1.67 is less than the table F value 3.49. Null hypothesis is accepted. There is no significant difference in the mean yield due to fertilizers. Now, in terms of p-value, hypothesis is to be tested against the probability value 0.05. The p-value given by Excel is 0.23. It is greater than 0.05. Since the p-value 0.23 is greater than the alpha 0.05, the null hypothesis is accepted. There is no significant difference in the mean yield due to varieties of potato. Inference. The quantity of all varieties of potatoes are the same. We shall test the second hypothesis. That is, there is no significant difference in the mean yield due to fertilizer. We shall do this first in terms of F values. Conclusion. In this case, the calculated F value 2.03 is less than the table F value 3.26. So, null hypothesis is accepted. Now, in terms of p-values, since the p-value 0.15 is greater than the alpha 0.05, the null hypothesis is accepted. There is no significant difference in the mean yield due to fertilizers. Inference. The quality of all fertilizers are the same. Our discussion ends here. We shall meet in the next video.